Hey guys, so I know that in class we did not get through all of the notes, so I thought I'd make a quick video so you guys could kind of get an idea for what we were going to finish talking about, and hopefully that way you can attempt your entire homework assignment, which was worksheet B. I know that we already talked about some of what I'm going to say right now. This is just to reiterate. I know I was going pretty quick through the notes. So anyhow, we talked about union and intersection, and we started talking about compound inequalities with and or. So I know that we already talked about this part in class, which you guys should have some notes on, but I do want to talk about the situations where we get no solution and situations where we get all real numbers. Again, I know we talked about this, but just want to make sure that it really sticks. So sometimes for an and problem, we can get no solution. So let's talk about what happens when we do get a solution. We get a solution with an and problem when the two arrows overlap. That happens in something like this, where we said x was greater than a. We said x was less than b. And the two arrows overlap right in the middle. Okay, so there is a solution in this case. What happens if there is no overlap? If there's no overlap, okay, the inequalities, they don't overlap overall or at all, we do end up with no solution. So there's no solution when the two inequalities don't overlap. So there's no overlap, okay, and it's an and problem. That's when there's no solution. Now, how about when there's all real numbers? This is going to happen when we have or problems specifically, okay, and when we have or problems and the arrows are everywhere. Remember, the or problem we shade wherever there's an arrow in general. So if you guys look above here, there's an arrow, so we shade to the right of B, and we also shaded to the left of A because there's an arrow over there. So what if I had something that kind of looked like this? It's an or problem, and I have my number line. What if my inequalities graphed like this? Okay, we got something going to the right over here. Over here we got something going to the left. It's an or problem, so I shade wherever I see an arrow. Well, I see an arrow to the left here. I see it in between the dots, and I see it to the right. I see arrows everywhere. That's when there's all real numbers. So when does this happen? This happens when there's an overlap and the arrows go towards each other. Okay, I wrote off the page, but you guys get the idea. Alrighty, let's go on. So now I am going to give an example of graphing an and compound inequality. So here, remember, we're going to be given these and problems like so with one inequality, and we actually have to split this inequality up. So in order to do that, we start at the number, and then we put a little box around until the end of the x. So I put a box right around here. Okay, and that's my first inequality, which you can clearly see I rewrote over here. Now, again, we always want that x on the left-hand side. So I'm going to rewrite this inequality, and I'm going to rewrite it with my x on the left-hand side. Notice the open part of the symbol is facing x. So when I rewrite this, I want to make sure the open part is still facing x. So I got x is greater than 4. I'm going to plot that on my number line. I'm going to put the 4 right here. Oops. I'm going to put the 4 right there. And let's number this. 4, 5, 6, 7, 8, 9. All right, so here I am graphing my 4. It's greater than, so I'm going to have an open circle, okay, and I'm going to go to the right. Now, the second part of my inequality is right here. Start with x and then go to the end of the number. So we got x is less than or equal to 10. So I'm going to draw my dot on the 10. And this is less than, so I'm going to the left. Drew my arrow. Now this is an and problem. And problems mean that I'm looking for the overlap. So where do these overlap? Wherever I see both arrows. So that's going to be between 4 and 10. Okay, so that's graphing an and inequality. So now let's talk about graphing an or inequality. For an or inequality, it's kind of nice. They're always going to be separated for you already. So here, number 1 is our first example. I have both of these, so I'm going to plot 0 and 5. So I have to look at both of my numbers and decide which one's bigger, which one's smaller. 0 is clearly smaller than 5, so 0, 1, 2, 3, 4, and 5. I'm making my number line. And I'm first going to plot x as less than 0. So I'm going to do an open circle on 0. Less is left, all right? And for my second inequality, I got greater than 5. So open circle on 5, greater than is to the right. All right, now this is an or problem. Or problems, I just shade wherever I see an arrow. Obviously not in between because there's no arrow in between the two pieces. So there's my first or example. And second or example is right here. This one, I have x is greater than or equal to 7, and I have x is less than -2. Remember, when I make my number line, I want the smaller number on the left-hand side, -2. So we got -1, 0, 1. Oh, man. I'm going to extend that. There we go. All right, cool. So my first inequality is going to be greater than or equal to 7. So I'm going to have a dot on 7 that's filled in because of the underline. And it's greater than, so we're going to the right. All right, second one, it is less than -2. So an open circle on -2. Less than is left. And so I am going to shade wherever I see an arrow. And that's that. So there are my two or problems. Now there's some examples below. This is using a verbal model, graphical representation, symbolic representation, and then it says alternate symbolic representation. A lot going on here. I'm going to go through just a couple of these, and let's get started. This one, x is greater than -6 and less than, this should say -1. This clearly just was bad typing. So less than, we're going to say -1. I think my key, I did +1, but for this case, we're just going to do -1. All right, so I need to make this into a graph and into the symbols. I think it's kind of easier to do the symbols first, so I'm going to skip over to that. Okay, now again, this said x is greater than -6. We can easily write that symbol as x is greater than -6. This is an and problem. I always make note of that. It also says x is less than -1. X is less than -1. All right, now what's the alternate symbol that we're talking about? That's when we write it as the compound inequality. Well, they're both compound, but the one is one single inequality instead of splitting it up into two. In order to do that, you guys, you always take the smaller number, put it on the left. -6 is smaller than -1. Take this bigger number, put it on the right. Put your x in the middle. And the symbols had no underlines, right? X was greater. See how the open part's facing the x? Make sure that we keep that. So x is greater than -6, but it is less than -1. We'll continue practicing that next week. Anyhow, let's use these ones, these two right here, to make my graph. All right. So we don't have to count out every tick mark, you guys, when the tick marks aren't drawn for us. I'm just going to go ahead and put -6 and I'm going to put -1, and they're both going to be open circles. So I'll do an open circle on -6, and then this one, x is greater, is going to go to the right. Second one, an open circle. There's no underline. Going to the left because x is less than. And where do I shade? I shade in between because I'm looking for that overlap. Ta-da! There's an and problem. And we'll do a quick or problem, and we will move on. I'm going to do the last one. X is the set of all numbers greater than 7 or less than 0. Keyword, or. Boom. All right, I like writing the inequalities first. So X is the set of all numbers greater than 7. How do I write that? X is greater than 7, or X is less than 0. Perfect. Now there's no alternate because remember I said you can't write that as a single one. It's always going to be separated. So we're just going to go right to my graph. All right, we got 0 and we got 7. Okay, X is going to be greater than 7. And it's in, you can't really see that. We're gonna try that again. We got X is greater than 7, no underline. Greater than goes to the right. And we also got less than 0, open circle, going to the left. And let's do some shading wherever we see an arrow because it's an or problem. And that's that. So that's just going from your verbal model to your inequalities or your symbolic representations and then to your graph. All right, guys, let's go on. All right, continuing on. Lots of stuff going on. This is kind of going backwards. This is saying, okay, let's write the compound inequality now. Let's write out the inequality. So this one is kind of strange because you can't really see where the arrows were originally. You just see that kind of bar from the -8 to the 0 for the first one. Let's zoom in on this. All right, so the clue here, guys, is that there's no arrows going to the left and right. It's just that bar that kind of starts here at -8 and goes to 0. This is an and problem. So this is like the one where you're shading in between. So what I usually do is I draw the arrows because it's going to be going this way from the -8. How did I know that? I know that because the shading's happening to the right. Okay, the shading's that red part. And where is it happening for the 0? It's going to the left because the shading's happening to the left. Okay, so this is an and problem because it's just shading in between. And how would I write that? Well, I know, look at the green one. It's going to the right of -8. So if I have X, I know it has to be greater than -8. And it's not underlined because it's an open circle. Now look at the second part. The blue arrow, that's going to the left of 0. So X is less than 0. And I actually have to underline that one because we have the circle filled in. How can I write that? I could, actually I'm done. I can just keep it like this, but I would want to make sure that I include the word and. And there is one more way to write that, so that I would accept this as a final answer, you guys. I would accept X is greater than -8 and X is less than or equal to 0, but I would also accept as 1, which would look something like this. We got the smaller one, -8. We got the bigger one, 0. X is right in the middle. We had an open circle and a closed circle. Either or would be accepted. All right, and we will now write our or problem. This one's a little bit easier, I think. Okay, so we are going to just take a look here. This is an or problem because the arrows are going opposite ways, and yet there is still shading. Remember, if they're going opposite ways for an and problem, there's going to be no solution because there's no overlap. So we are going to first take a look, and we'll see that x, we got something going on with negative. I usually write down the x and the -8. Is it greater than or is it less than? Well, it's going to the left, which is going to be less than. And is it less than or equal to? It is. It is because it's shaded in. That's the first one. Second one, I have an x and a -6. Now I need to figure out my symbol. It is going to the right, which is going to be greater than, and I don't underline because the circle's open. Now I have to also realize that this is an OR problem. This is an OR problem, again, because the arrows are not overlapping, yet they're still shading. So if they're still shading and there's no overlap, that means it's a definite OR problem. So this one we said was x is less than or equal to -8, or x is greater than -6. Alrighty, so we're almost done. This is some examples that we're going to go through. These are some special situations, okay, you guys? So here's a situation. It says x is less than 3 or greater than or equal to -6. So I'm going to write that out first. So x is less than 3, okay, or x is greater than 6. So I want to decide, does this work? Well, it absolutely does. You can see this is already graphed for us because this is a completed example. We got x is less than 3, which is graphed, open circle on 3, going to the left, x is greater than 6. Ooh, that should be greater than or equal to, shouldn't it? All right, because it's a shaded in circle, so it's greater than or equal to 6, going to the right. Now, that's an OR problem. That works, okay? What if this was an AND problem? If this was an AND problem, again, that should be underlined. We got x is less than 3, okay? So we're graphing it. It's going to the left. We got x is greater than or equal to 6, going to the right. For the AND problem, we're looking for the overlap, and there is no overlap. So that's a no solution. All right, so let's do some more examples like this where we have to do this ourselves. It's going to be the same statement for an and then for an OR, okay? And we have to decide, obviously there's going to be different solutions for whether it's an and or an OR. All right. Here we go, the fun stuff. Whoopsies, my bad. All right. X is greater than 5 and x is less than 10. So x is greater than 5 and x is less than 10. Let's plot this baby. We got 5, 6, 7, 8, 9, 10. Okay. And I'm going to put an open circle on 5. X is greater than 5 is to the right. And for x is less than 10, we got an open circle on 10, less than, to the left. And we want to shade. I am shading in between the 5 and the 10 because there is an overlap. So what's my final solution? My final solution is exactly the original problem. Okay, so if there is an overlap, you guys, then you're just going to write for your solution exactly the problem as it is. Because it's a true problem. It works. All right, now let's do this for an OR. For the OR, we got x is greater than 5 or x is less than 10. All right, it's the same exact problem. So we're going to go with 5, 6, 7, 8, 9, 10. Okay, and again, I'm going to go x is greater than 5. There's no difference. The only difference here is the OR part, so we need to be very careful on that part. We got x is less than 10. And then I'm going to shade. It's an OR problem, which means I shade wherever I see an arrow. So I see arrows here. I see arrows in between. I see arrows to the right. I see an arrow everywhere. So what's my actual final solution? If it's everywhere, the shading's everywhere, guys. This is all real numbers, which we've learned before. Ms. Barrett likes to call it infinitely many solutions. Okay, I would accept either of these. All right, let's see, we got x is less than or equal to -2, and x is greater than or equal to 5. Okie dokie, we got x is less than or equal to -2. X is less than or equal to -2. I'm hoping that we're getting better at writing these out. And then we got x is greater than or equal to 5. X is greater than or equal to 5. Perfect. Let's plot this and graph. X is less than or equal to -2. Cool. So we got a closed circle on -2, and it's going to the left because it's less than. Next one. X is greater than or equal to 5. So closed circle on the 5. To the right. This is what type of problem? It's an AND problem. So I shade the overlap. Oh my goodness, where's the overlap? I don't see it. It doesn't exist. There is no overlap. I don't know what to do. Actually, I do know what to do because I'm a smart student and I listened to Miss Barrett and I know that when there's no overlap for an AND problem, the answer, the final solution, is that there's no solution. So my final solution is no solution. Okay. And finally, we got x is less than or equal to -2, or x is greater than or equal to 5. Same exact problem. Okay, just it's an OR problem. So this is going to be x less than or equal to -2, or x greater than or equal to 5. Okay, so I'm going to plot this. Here we got and closed circle on -2 to the left. We got a closed circle on 5 to the right. It's an OR problem, so where do I shade? I shade wherever I see an arrow. So what's my final solution? Okay, my final solution is the problem exactly as I have it. Okay, so it's x is less than or equal to -2, or x is greater than or equal to 5. You don't need to rewrite that over and over again, but that would be my solution. Okay, so there's our notes for this page. All right. Now the next page gets even more interesting, but I'm going to stop here because this is a long video as it is, and we will pick up with this on Monday. This was the page right here that we didn't really get all the way through, so I want to make sure that we had that, and you guys could at least get a good idea of what's going on before we pick it up on Monday. So I'll see you guys Monday. Have a good weekend, and we'll talk to you later. Bye.